Hello and howdy, ladies and gentlemen. Root Beer here, and I'm very excited to share something with you all. So hopefully you're all doing well and you're eager for a new challenge. What I've got here is actually I dug this out of the archives. Well, not my archives. I've got some friends who've got extensive sets of math contests. But look what I've got here. There we go. Lighting is always fun. But we've got the Ontario Senior Mathematics Competition. You can see it's from 1968. There you go. Webcams and lighting are always fun. But yeah, here we go. We've got the Ontario Senior Math Competition. This is the first Ontario Senior Math Competition. It's another University of Waterloo math contest, like I'm known for doing. But this one's a little older than what we would usually expect. So a little bit of history. I believe the oldest paper Waterloo ever put out was 1963. I don't have a copy of one of those on hand. If you guys like this little mini fun series, I can try and get my hands on a copy. I don't know how well that'll work. But this is the oldest senior paper. I think before it was just the Ontario Math Problem Competition or whatever it was called. And then in this year, they split it into a senior and a junior. The senior eventually evolved and split into two papers, one for grade 13, because they had grade 13 back then. Actually, it's not so long ago. It's 20 years ago they got rid of grade 13 at the time of recording. But it split into a grade 13 paper you may have heard of called the Descartes Paper, which actually I have one here for other reasons. This is the 2002. This is actually the last year of the Descartes. If you want, maybe I'll go through that someday. Let me know. Let me know in the comments down below. Cast your vote. So it was a grade 13 paper, the Descartes Paper, and it was the one you wrote to get a good scholarship. And it also split into the Euclid. So you had the Euclid and the Descartes, and they were very similar papers, and then eventually the Descartes went away, and now we just have the Euclid. The junior, the Ontario Junior, so not this one, but the other one from 1968, eventually split and became the Pascal-Kalian Fermat that we know today. Okay, so fun little bit of Waterloo math contest history. But I dug this out of my friend's files. He's got all the old Descartes back to before it was a Descartes. And so I didn't get an electronic copy. As far as I know, no one has electronic copies. But what I did, because I like working from an electronic copy, is I basically retyped the whole thing out in nice, neat, and I made sure all the margins were as best I could. And I'm still, there might still be a typo or two or things like that. But we got our whole paper here. And, things like this star diagram, they were actually basically drawn in by hand and then photocopied. So here's the paper. It's 13 questions, and as we can see, our last question here, if you just want to very quickly skim it, talks about multiplicative groups, because back then, apparently a group theory question was fair game for a late-year high school student. That's kind of nifty. So there's lots of different types of questions you can find on this paper here. There's 13 of them. I'm just going to very quickly read the instructions for you. As usual, I'll be going through one question at a time. Now, the time limit is 2.5 hours, not unlike the Euclid papers that you write nowadays. They give you just a little bit of advice. Better to do a few complete solutions than a whole bunch of comments on a lot of questions. You only needed to write 10 questions, not unlike today's Euclid, except they only give you 10 questions, whereas this contest, the Ontario Senior, gave you 13 questions. And you did have to tell them which ones you were doing. So you could make little comments on all of them, but at the end you got to say, I did 1, 2, 4, 5. Please ignore question 3. Don't mark that one. Okay? Now you'll notice there's a lot less instructions on this one here. And that's because, well, they didn't have to say things like no calculators, because calculators weren't that big of a thing back then. People did not have these handy for math contests. So any of the calculations we're going to do, I'm going to do it old school, calculators going away. Any of the calculations we have to do, we're going to do them by hand. So if we got to do a long division, we'll do a long division. If we have to calculate a square root by hand, we will calculate a square root by hand, and all those sorts of things. So it's a very nice little contest, and then it gets right into it. I'll be doing one question at a time. As I said, this is my electronic copy. I did fix one or two things. For example, I seem to recall in the booklet that I have, there's actually a typo in this question. I think there was an X. Actually, let me grab my copy and check. Yeah, question 12 has a 3x plus 1 instead of a 3r, and that would make the question downright impossible. But I do also have this. Look at that. This is solutions and discussions, and it's very old. I'm not going to go through. I'm not going to read through this before I do the questions. But the proper solution, it was noted in the file that this came out of, that the proper wording of question 12 is somewhere in here. Question 12 was a little later, wasn't it? Oh, yeah, there he is. So 3r plus 1, so I know that's right. But this is great. This basically told you how to mark, gave you a bunch of solutions, and then it also had remarks like, many students who could not do part A nevertheless earned marks for part B, fun things like that. So these used to come out with the papers as well. But as I said, we'll keep the solution book away, and we're just going to go through this. Now you might notice here, question 12, like the group theory question 13 down here, it does not look like the sort of thing you see in high school. We don't really do power series in high school and infinite convergence and things like that. But you got to remember, this was being written by students in grade 13. These are people who've had an extra year of high school math. They also focused on different things, trig identities, combinatorial identities. They really liked their geometry, circle geometry, and things like that. So it's going to be, I think, fun and interesting to see what they used to do so many years ago, but also to see questions that we don't see on math contests anymore. Anyways, that's enough of an introduction. As I've already said, I'm going to go through one question at a time, and in this video, question at number 1 is it. Okay? So I'm expecting the questions to increase in difficulty as we go down, but honestly, I don't know. This is early days for them. They might not have decided that that's the way to do things. But I'm hoping question 1 is easy and question 13 is hard. We'll see. We will see. What have we got here? In a certain school, there are 2 grade 13 mathematics classes. One class contains M1 students and has an average mark of A1 on a test, where the total possible mark is N1. The other class contains M2 students and has an average mark of A2 on the test, where the total possible mark is N2. Calculate the average percentage mark for grade 13 students, so ignoring who's in what class. So this question is just saying, if you've got 2 averages that can't easily be compared because they're not out of the same amount, how can you get an overall percentage? How can you combine them? And this isn't too bad. So let's take a look-see here. So they want to talk about percentages. Well, class 1, I'll call it, has average percent. How do you calculate percent? You take the mark, in this case the average class mark, out of the total number of marks, and you multiply by 100%. Similarly, class 2 has the average percent A2 out of N2 times 100%. Okay? Now, putting this more into numbers, this is like saying, I do this calculation, and class 1 has an 80% average, and class 2 has, say, a 90% average. But if we're going to combine the classes, we can't just say, 80 and 90 averages 85. Right? Because the number of students in each class could be wildly unequal. There could be 20 students with 80% as the average. Okay? So when we say the class average is 80%, basically what you can do is you can pretend, instead of the students getting the marks that they got, you can pretend all 20 of you got 80%. And that'll give you the same average in the end. So it's as though everyone got 80%. So how do you average 20 80% and 10 90%? So you have to do what's called a weighted average. Okay? So what we're going to do is we're going to take each of those 80%, add them up, so multiply by M1. Each of those 90%, add them up, and divide by the total number of percents. Same way we usually do averages. Okay? But we just have to be careful. And I'm not saying the actual average. They're not giving me numbers, so I don't know anything's actually 80%. So to find total average, we perform the weighted sum. So percent class 1 earned times how many students earned that percent class 2 earned. Oops, can't forget the 100% there. Although we will be able to factor out 100% in just a moment. Times the number of students in that class who earned that mark, essentially, divided by the number of students we have in total. So I can take out the 100%, and I'll be left with A1 M1 over N1 plus A2 M2 over N2 all over M1 plus M2. Now, I probably wouldn't leave it like that, just because I know things like back then, radicalizing the denominators was a really popular thing. So I know that they liked certain ways to have fractions. Certain fractions were only considered complete, or things were only considered complete answers if they had a very nice form. And I feel like fraction plus fraction inside another fraction isn't nice. So I want to simplify this a bit more before I declare us to be done. So let's combine the top into a single fraction. Common denominator of n1 and 2 will be nice. So a1 m1 and 2 plus a2 m2 and 1. And now we can simplify the fraction being divided by something. So we'll say 100% times n1 n2 m1 plus m2. And then on top, A1, M1, and 2, plus A2, M2, and 1. And, you know, if you really like order and balance and things like that, you might even rewrite it like this, A1, M1, and 2, you know, expanding the bottom there to be N1, M1, and 2 plus, and then on top, A2, M2, and 1. Let's put the N1 here, put the M2 here, and the N2 here. That would be another way to write it. Okay? But there, that's it. That's how you calculate the average over a total number of students when they're separated into two groups, and you only know the averages for those groups. And actually, if we were to grab the solutions, I bet something similar would be in here. Okay, so I'm not going to do this for every question, but Here's where it starts. Problem number 1. And then, yeah, actually, their answer. Forgive the lighting. It's about to go freaky as I get close to the camera. But you'll notice their answer right there looks a heck of a lot like the first answer I have up here. This one. So we're off to a great start for this paper. Out of curiosity, were there fun comments? Oh. Actually, remarks. We aim to make the first 6 problems reasonably easy, so hopefully they are. Main weakness was students had problems because they didn't actually have actual numbers. They were working with variables. One student made up a numerical example, didn't get many marks. Yeah. Simple, literal problems of this nature are an excellent test of real understanding and mathematical thought. I wish they gave these out still. When we mark down in Waterloo things like the Euclid, we don't get fun comments like that. We just sort of get the solutions. Okay, but there we go. That's question number 1. Up next, of course, is going to be question number 2, and we'll take it from there. So if you're interested, if I've piqued your interest, if you want to see what a really old math contest, but still from Waterloo looks like, then join me for question 2, 3, all the way up to that group theory question in 13, whatever that's going to be. Okay? Thank you guys for watching. So long for now.